All right, so I want to go over a real interesting principle of the Clovis ferrule here, and also by design. We did a lot of airflow simulation, and as air flows past the ferrule, you can see the only thing exposed is a very, very small surface area of our wing blade to catch, hide, and engage our cutting blades and instantaneously explode into the entrance hole of the animal. And as the air flows down the ferrule, you'll notice everything's sleek and aerodynamic from leading tip all the way to the back end, but then something really different happens here with this flare at the end, and this serves about three huge reasons. And a lot of people probably look at it and not even notice why there's a flare back here at the end, but here's why. So number one, the flare is 10% wider than the most arrow shafts or smaller diameter arrow shaft. And what that does is that allows the Clovis to penetrate very deeply, especially you'll feel it when you pull out of your target in practice mode. These wing blades curve forward, actually push target material forward, and then they engage hide quickly when they actually ram into hide because they're blunt. But as you're practicing, then that pushes target material and foam forward. And so when you go to pull the arrow out backward, it removes easier, probably twice as easy. I need to put a force sensor on this, but probably twice as easy as a standard field point, which is pretty incredible. And then on the back end, the ferrule is going to be 10% wider than the arrow shaft itself. So what you want to do is, and this is a huge property of that Ashby's penetrative studies, and that is get this ferrule wider right here just a little bit. By 10% is what they found is best, because then it doesn't drag on the shaft all the way through the animal's torso, and you have much, much less surface area dragging, and you're going to get a lot more penetration. It's kind of analogous to a long time ago I had a Ford 9N tractor, and I was pulling a downed tree, and I didn't delimit first. I got on the tractor and had it hooked up with chains, went to pull it, and the entire front of the tractor lifted off the ground because each little limb was touching the ground, which gave me so much surface area of friction that it actually held back the whole tractor. So I got off and cut all the limbs off the tree with the trunk, and then I could pull the tree very easily. So kind of analogous to that drag factor here. It's amazing what it does, and you'll see that in ballistics gel, because what ballistics gel does is when it hits and goes through ballistics gel, as I spoke about before, it doesn't open up back here like animal tissue when it cuts through. Ballistics gel actually wraps around this ferrule and then grabs a hold of the arrow shaft again, and it doesn't act like animal tissue at all. But that's by design because it's meant to stop bullets. So the second property of this ferrule flare is going to be aerodynamics. So the Magnus effect is that self-centering effect, and as air moves along the ferrule body and then it hits that back edge, it's going to be flung off the back edge as a flare, and actually the air flowing across this ferrule creates a differential pressure, and it self-centers this broadhead in the air as it's moving at a high speed, analogous to a beach ball and a fan airflow. It's going to keep that beach ball centered, and that leads to our extreme precision of our Clovis broadhead. And then the last thing is going to be an effect of design, and that is the air coming off of this ferrule can come off clean without turbulence or eddies. And what you have is, if you look at a new Ford F-150, my F-150 has this on it, the little flare at the top of the tailgate. It's extended a little bit as a lip, and that's going to let that air run cleanly off, laminar flow, instead of you get turbulence back here. If it doesn't, this is going to allow the air to laminar flow off the back end of this ferrule, and you're going to get a lot less resistance going through the air of that ferrule design. So the back end of the Clovis has a huge part, very simple in design, very simplistic, but a huge part in its performance.